The next question. An inverted cone has a depth of 10 centimeter and a base radius of 5 centimeters. So I'm going to draw a cone like that. So I have a cone and I marked the radius as 5 and the height as 10 centimeter. Now they say water is being poured into this at the rate of 3 by 2 cc cubic centimeter per minute. Find the rate at which the level of the water is rising when the depth is 4 centimeter. So this is the vessel which is not under change. What is under change is the water cone which is being formed inside, because you are going to pour water into this at the rate of 3 by 2 cubic centimeter per minute. So it will form a water cone which is the variable cone, and that's where we introduce the variables R and H. So I have marked the water level here and I say at some time t, the radius is r, the water cone which is formed there has a radius of r and the height h. But then I can see that I can actually make a relationship between r and h. I'm going to go for a bit of labeling in this. So like I marked O here, AB, so I have a triangle OAB, then I have a triangle OPQ. And if you look at these two triangles, 90 degree, 90 degree, and then both the triangles, triangle OAB as well as OPQ, has a common angle here. So that's angle by AA similarity. We say the two triangles are similar. Triangle OAB is similar to triangle OPQ. And if two triangles are similar, their corresponding sides will be in the same ratio. That's OA by OP. That's height of the small triangle by height of the big triangle. That's OA by OP will be same as the base of the small triangle by base of the big triangle. So I write it that way, OA by OP is equal to AB by PQ. And I put values into that. OA is marked as H. So I have H by OP is marked as 10. So height is H by height is 10 is equal to the base is R by base is 5, R by 5. I can cancel 5 with 10, giving me a 2 there. So I get H by 2 is equal to R. So I got a relation connecting R and H. Now what's my question? Find the rate at which the level of water is rising when the depth is 4 centimeters. So I'm going to write these rates of changes. They said water is being poured into this at the rate of 3 by 2 cubic centimeter per minute. So that means that's the rate of change of volume. So that's going to be dV by dt. dV by dt is 3 by 2 centimeter cubed per minute. What am I looking for? Trying to find out the rate at which the level of water is rising. That is dH by dt is equal to question mark. That's what I'm trying to find out. The rate at which the height is increasing. Now I need to establish a relationship between V and H. V is equal to 1 by 3 pi r squared h. That's the relation between V and H. But we see that also R is appearing. But R is also a variable. So I cannot have R in here because I wanted only a relation between V and H. So I go back to equation number 1 where I found R is equal to H by 2. So I'm going to plug in that value here. So R will be replaced by H by 2 here from equation number 1. Because I wanted only a relation connecting V and H. So V is equal to 1 by 3 pi into R is H by 2, the whole square into H. Do a little bit of simplification. This is going to be H square times H is H cubed, and that's 4, 3s are 12. So this is going to be V is equal to 1 by 12 pi H cubed. And once you get this relation, we are ready to differentiate with respect to T. So differentiating with respect to T, we get dV by dt is equal to 1 by 3 pi, 1 by 12 pi stays there. H cubed becomes 3h square into dH by dt. H cubed derivative is 3h square into dH by dt. dV by dt value we know 3 goes in 12 4 times, so I have pi by 4 h square into dh by dt, and I'm trying to solve for dh by dt. So this 4 should get cross multiplied. That's going to be 12 by 2, 6, and then this pi h square will go down to the denominator. So I get this way, which is 6 by pi h square. And finally, you have the value. They said the depth is 4, h is 4. Submit that value, and you get the answer.